How do you get from a solar power system to inside the human body? With ingenuity, partnering with NASA, and a little bit of risk. In 1987, a small firm in Pacoima, California called Ultramet received a Small Business Innovation Research, or SBIR, contract from NASA's Glenn Research Center to develop a lightweight ceramic foam material. From the new material, the company successfully produced high-quality reflectors that could be used as ground or space-based solar collectors. With SBIR funding from other agencies, they further advanced the technology for a number of aerospace and industrial applications. Ultramet then found a new use for the foam technology, a metallic version now known as Hydrocell. Because of its high strength and porous structure, Hydrocell is an ideal biocompatible material for many bone replacement or repair applications. Ultramet has since licensed Hydrocell to another company. Ultramet began as a developer of advanced materials for extreme environments.
When we originally were founded, our manufacturing process only allowed us to fabricate approximately a half a dozen materials. With the inception of the SBIR programs, it allowed us to develop new materials in ceramics and composites, and it really opened up our ability to provide a lot of different materials as opposed to just the original 6.
At its core, Ultramet specializes in chemical vapor deposition, or CVD fabrication of parts and coatings. With the CVD process, the company creates new materials and products that have enhanced properties like high strength, lightweight, and temperature resistance, and are cost-effective. Under another SBIR contract from Glenn, the firm produced new materials for rocket thrusters. With additional support from Aerojet, TRW, Loral, and other aerospace companies, Ultramet further developed the thrusters, which are now being used in space for various satellite programs. With SBIR funding, the firm also worked with Glenn to develop materials for turbine blades that would be used in aerospace propulsion and power system applications. The technology was transferred into the fabrication of ceramic-to-metal joints that are used by both the Army and the Navy in different applications. While working with NASA's Marshall Space Flight Center under an SBIR contract, Ultramet developed new ceramic matrix composite materials for high-temperature environments. That material development is part of the Integrated High Payoff Rocket Propulsion Technology Program. The program, a collaboration between NASA, the Department of Defense, and industry, focuses on the next generation of materials and processes needed for future space systems.
The materials and systems that we use, they're all somewhat interrelated. There are key select core technologies that we try to co-develop with other agencies, and with the goal of being able to promote that technology for several different types of applications.
Today, with SBIR funding from Johnson Space Center, the company is working on new materials and manufacturing for liquid rocket combustion chambers and hypersonic vehicle thermal protection systems. Over the years, these partnerships through the SBIR program to develop and transfer advanced materials have proven to be very successful for Ultramet, NASA, and others.
We have to be willing to accept the fact that not all of these technology and developments are going to be successful, and that's the sort of entrepreneurial spirit of this whole program, is that it takes a little risk to develop these materials, but in the end you get high payoff.